Hi guys, it's Ashraf from WiZ.edu, and today we're going to be doing slightly more difficult examples on type 2 trig questions, which are equations with restrictions. So for our first question, we are asked to determine the value of sine theta plus 1 over cos theta if root 7 tan theta equals 3 and cos theta is less than 0. So our first step is to get in the form trig function equals number. So we know that root 7 tan theta equals 3. We can divide by root 7 to isolate our tan theta, and that becomes 3 over root 7. So our second step is to determine the restriction, but the restriction we are given here is a bit different to what we've seen before, because we are told that cos theta is less than 0. So what does that mean? Well, if you have your number line here, right, with 0 over there, they're saying that cos theta is less than 0. So it must be on this side of our number line if this is positive and that's negative. So what they're telling us basically is that cos theta is negative, right? So we know from the cost rule that cos is positive in quadrants 1 and 4. So if cos theta is negative, we must be working with the second or the third quadrant, right? And from our question, we know that tan theta equals positive 3 over root 7. So we know that we must be working with a quadrant where cos is negative and tan is positive. So we know that tan is positive in quadrants 1 and 3. So our common quadrant between these two is 3 because cos is negative in quadrant 3 and tan is positive in quadrant 3. So we must be working with quadrant 3 and theta must be an angle in quadrant 3. And we know that in the third quadrant, x is negative and y is negative. So we'll use that a bit later. So now we can put in our definition for tan, which is y over x, and that gives us 3 over root 7. So we know that y must be 3 and x must be root 7. But we know that we've just determined that x is negative and y is negative. So that's negative 3 and negative root 7. And now we can go ahead and use Pythagoras to solve for r. So we know that r squared equals x squared plus y squared. Reason, Pythagoras, right? So that's going to equal negative root 7 all squared plus negative 3 squared. So that's positive 7 plus 9, which is 16. So r squared equals 16. We can square root both sides and get r to be positive 4. And r is definitely positive because it's a length, and a length is always positive. So we've solved for our three variables. So we know that for theta, x in this case is going to be negative root 7. Y is going to be negative 3, and r we've calculated to be positive 4. So we can go ahead and substitute these into the ratios. So we know that the definition of sine, well, let's just write it out first, plus 1 over cos theta. We know that sine is y over r, okay? And that cos is x over r. So let's substitute our y, r, and x's in. So that's going to be negative 3 over 4 plus 1 over r is negative root 7. That's going to be over r of positive 4, right? So we get negative 3 over 4 minus 4 over root 7. So now this is slightly complicated to simplify. What I'm first going to do is rationalize the root 7 in the denominator by multiplying this by root 7 over root 7, which is essentially 1 because root 7 over root 7 is 1, but it gets rid of the root 7 in the denominator. So that's negative 3 over 4 minus 4 root 7 over 7. And now it makes it slightly easier for us to subtract. So our lowest common multiple between 7 and 4 is 28. So we'll multiply this negative 3 over 4 by 7 over 7, and we'll multiply this bit by 4 over 4, so we get a common denominator. So that would eventually give us negative 21 minus 16 root 7 all over 28, because our denominator is now common, and that would be our final answer. So you can see that the only hard or slightly more difficult bit of this question was the cos theta less than 0, or the restriction, which you had to infer that cos being negative in the second and third quadrants, and using that in conjunction with tan being positive 3 over root 7 and tan being positive in 1 and 3, and finding that 3 was common between these two. So that was what made the question slightly more difficult. So for example 9, we are told that sine theta equals 3 over 5 and theta is less than 90 degrees. So let's start with step 1. Step 1 is already done for us. We're already in the form trig function equals number, because sine theta equals 3 over 5, right? And our restriction is quite easy, because we told that theta is less than 90 degrees. So we must be working with the first quadrant where both x and y are positive, right? So we can go ahead and extract our variables and solve for x, using Pythagoras, because the definition of sine is y over r. So we have y being positive 3 and r being positive 5. So x, because of Pythagoras, r squared equals x squared plus y squared, right? Reason is Pythagoras. So 5 squared is going to equal x squared plus 3 squared. X squared will be 25 minus 9, which is 16. We can square root both sides, and we get x to be positive 4, because we know we're in the first quadrant. So now we have our 3 variables for theta. So for theta, we know that y is positive 3, x is positive 4, and r is positive 5. So it's simple to solve for tan theta, because we know the definition of tan is y over x. We can merely substitute y as 3 and x as 4 to give us 3 over 4. The issue comes in with cos 360 minus theta. This is why it's a slightly more difficult question, because you have to make use of your supplementary reduction formula, because you can't go straight from here and say that this is equal to x over r. No, because we have a 360 minus theta here, and we only have x, y, and r for theta. So 360 is a supplementary angle, and we know S for supplementary, S for same. So our trig function will remain the same here, equals cos theta, right? And for sine, we look at which quadrant 360 minus theta was in. 360 minus theta was in the fourth quadrant, and because of the cost rule, we know cos is positive in quadrant 4. So cos 360 minus theta is exactly the same as cos theta. And now we can put our x over r in there and get x over r being 4 over 5. So cos 360 minus theta is 4 over 5. So for our next example, it's something similar you can see with the 180 here. We are asked to determine the value of 1 over cos theta and tan 180 minus theta if sine theta equals 12 over 13 and theta is between 90 degrees and 180 degrees. So we are already in the form trig function equals number, right? Because our trig function is isolated on the left-hand side. We can take a look at what quadrants we'd be working with. We know that theta is between 90 and 180, so we must be working in quadrant 2, where x is negative and y is positive, right? So next step is to put in our definition for sine, which is y over r, and extract y as 12 and r as 13. Now we will use Pythagoras, r squared equals x squared plus y squared, to solve for x, okay? So r in this case is 13, x is unknown, and y is 12. So x squared would be 169 minus 144, which is going to give us 25. Square root both sides, right? And we have x to be positive 5 or negative 5. But in this case, we'll choose the negative because we know we're working in the second quadrant where x is negative. So we'll say that x is negative 5. So now we have our three variables for x, y, and r. So I can go ahead and write those over here. So for theta, we know that x is negative 5. We know that y is positive 12 and r is positive 13. So 1 over cos theta is going to be 1 over x over r, which would simplify to being 1 over negative 5 over 13, which eventually simplifies if we invert that to being 13 over 5, and that's negative. And if you further wanted to write that as a mixed fraction, you could say that's going to be negative 2 and 3 over 5. Now, the next question is what makes it slightly more difficult. We have to use our supplementary reduction formula again, because we can't immediately substitute y over x for tan, because we don't have x, y, and r for 180 minus theta. We have an x, y, and r for theta only. So supplementary reduction formula, 180 is a supplementary angle. So we can simplify that to tan theta. But remember, for our sine, you have to look at the original. This is critical in this question, so you don't get it wrong, because 180 minus theta, right, lies in the second quadrant because it's 180 pulled backwards. And we know that in the second quadrant, tan is negative because it's only positive in 1 and 3 due to the cast rule. So that's going to equal negative tan theta. So when we're substituting in, we have negative y over x, not positive y over x. So that's going to be negative into 12 over negative 5, which is going to give us positive 12 over 5, or 2 and 2 over 5. So that would be your final answer for this question. So for our next question, we are asked to determine the value of 5 over sine 90 minus alpha minus 3 tan alpha if tan alpha equals 12 over 5 and alpha is between 0 and 90 degrees. So we are already in the form of trig function equals number over here. Tan alpha equals 12 over 5. And our restriction is quite simple because we know that alpha must lie in the first quadrant because it's between 0 and 90 degrees. And x and y are both positive in the first quadrant. So we can go ahead and extract y and x by putting in our ratio there. We know that y must be positive 12, x must be positive 5, and we can use Pythagoras to solve for r. So that's the reason is Pythagoras, right? So r squared equals 5 squared plus 12 squared, which is 25 plus 144, which is 169, right? So if we square root both sides, we get root 169. R is equal to positive 13. Okay, so now we have our x, y, and r for alpha. So for alpha, we know that x, y, and r, x is positive 5, y is positive 12, and r is positive 13. Now we simplify this fraction over here. The only complicated bit is the sine 90 minus alpha, because we have x, y, and r for alpha, not 90 minus alpha. So we have to somehow manipulate that into becoming alpha. Now we know that 90 is a complementary angle. So we can use our complementary reduction formula here. So that's going to be 5 over co for complementary angle, co for complementary. So that's going to turn from sine into cos alpha. And because sine 90 minus alpha was in the the first quadrant, cos alpha is going to be positive because sine 90 minus alpha was positive. And that's going to be minus 3 over tan alpha, right? So then we're going to get 5 over x over r if we put our ratios in, minus 3 over tan is y over x. Now we can substitute our x, y, and r in there. That's going to be 5 over 13 minus 3 over 12 over 13. And from this we can simplify. We can say that's going to be 5 multiplied by 13 over 5 minus 3 multiplied by 13 over 12. Now we can do a bit of cancelling here. We can cancel that 5 with that 5 there. 3 can cancel with 12, and that becomes 1 over 4, right? So now we can go ahead and further simplify this to being 13 minus 13 over 4, which would then be 52 over 4 minus 13 over 4. If we multiply this by 4 over 4 to get our denominators the same, which then gives us 39 over 4, which if you wanted to simplify further as a mixed fraction would then be 9 3/4. So that's our final answer for question 11.